Hi, we are stronger together, and this is our project, Smart Microgrid Ecosystem. The objective of this project is to support rural farms by developing a self-sustained smart microgrid ecosystem by integrating renewable energy, intelligent storage, and IoT-driven automation, and also reduces dependence on unreliable grid supply at rural areas, and finally, to optimize agricultural productivity and sustainability.
Smart gravity battery that can store energy in a clean way and also reduce the chemical waste of lithium battery.
Good morning, sir. I'm Yongbing and I'm here to present my MSES project. Over here, I already built the smart gravity battery system, which I want to convert the excess solar energy to potential energy to store it. And then over here, I already connected the microcontroller to my two current sensor and the motor driver. So other than that, I also connect to the LED strip and the light sensor. So over here, I built a graphical user interface to show all relevant data inside the GUI. So for my motor, I got two different modes. One is the manual mode and the other one is the auto mode. Inside auto mode, I already built the fuzzy logic system inside the coding. So my auto mode will be depends on the speed level and the brightness value. So if the brightness value and the speed level is almost 100%, then it will show a green color light. And if these two values, it will show yellow color light. Over here, it will give yellow color light, which means the index is falling between 0.5 to 0.7, and the motor will be running at a very low speed. If I turn the speed level to a higher value, the fuzzy logic will give a higher output index. So the color will be green color light and the system will running at full speed. So when I click on manual mode, and then the system is supposed to be run at full speed. So it will going up. And then when it reaches the top already, then over here it will show a purple light. So when the purple light is showing, and then I can click on release. The color become blue color, and this when this thing is going down, then this one will means the electricity is charging from the generator, which is the motor. Okay, so the efficiency will be showing out over here, which is the output power divided by input power. Additionally, to execute the manual mode online and the communication with other components in the system, I designed a workflow that allow a mutual communication from our system to the MQTT broker. And it will send the data to NORAD and ultimately store into the database. The same operation will also be applied to our group component system also. By connecting the system with NORAD and MQTT, which is a IoT connection, we can record the historical data and visualize the trends over time. Then it can be sent to NORAD and saved to Postgres database. So inside Postgres database, I also created the table to store my relevant data. So ultimately, it can be shown as something over here. Okay, that's all for my component. Thank you, sir.
Solar panel dust detection and cleaning system.
Hello sir, my name is Kalyan Samazinga, TP073538 from Group 1. So this is my individual component, solar panel dust detection and cleaning system. So these two LDRs are used to detect the brightness of the sunlight, and if the brightness of the sunlight in this region is higher, the motor will rotate to this side, and for this side it will rotate to this side. You can see in the OLED display like for this side, if the brightness is high, you can see SG rotating to 135 degrees, and for this side, if the brightness is high in the OLED display, you can see the SG is rotating to 45 degrees. So the OLED display shows the current voltage generated by the solar panel, and in the first row you can see water pump is currently off. So this is the button that I use to switch on the water pump. When I press it hold, you can see the water pump is on. So this is the rain sensor, and currently since there is no water, you can see in the OLED display there is no rain. Rain is no. So if I put some water in the OLED display, you can see rain is.
IoT enable Agro monitoring system, which can monitor plant healthy and delivery pH control nutrient water.
Hi sir, my name is Wang Chi Kai. So today I'm going to present my individual component. So for my individual component, I have used ESP32, color sensor, alarm, LED, and the resistor, and one more is the real-time clock modulars, and one more is the moisture sensor. So the output, we got two output, which is the moisture sensor. We will sense the moist level. So after I putting inside, moisture will be updated, which is 99. So after I taking out, it will show 0. Yeah, it will show 0. So the second output, which is the color sensor. So if got leaf or yellow color paper senses over there, so both of the LED will be attracted and the alarm will sound different. That's all for my presentation.
Next, we have smart water fertigation system, which harvests rainwater and supplies pH-controlled water. This achieves one of the Sustainable Development Goals, which is to have clean water and sanitation.
Hi, my name is Loren Chong. My TP number is TP074543, and this is my water tank system. And let me introduce my system first. So this is the water pump to pump in water if it gets below a certain threshold by using this ultrasonic sensor to sense the water level. And this water pump right here is to send water to the solar panel cleaning system, and this water pump is to send the water to the second tank for the pH adjusting. And it will pump the water to sprinkle to the plant. And this is my GUI, which shows the soil pH, water pH, and also water level. Okay. So now let me demonstrate my system. So currently the pH level, the soil pH is 7. And so if I trigger it using this terminal, it will just pump water from here to the water tank and it will sprinkle right out. So now I'll change the soil pH to a lower one, like 5. And you can see the pH now is 5. And I'll trigger it. And you can see the water pumping from this tank. And it will add in baking soda to make the pH lower. And it will water it. And if I change the pH level to 9, and if I trigger it, it will pump water in, and this will pump vinegar in, and it will pump right out. Okay. So that's about it. Thank you. Hi, we're group 1, and this is our project. So this is our private MQTT server, which has its own username and password. So after I connect it, it will show our whole projects, the database, which is four of this system. Yeah. And this is our GUI for the project. And as you can see, there's 4 of these projects on this GUI. So as you can see, the brightness from the smart gravity battery system is controlled by the light sensor on the solar panel monitoring system. Like this. And as you can see, the brightness here is increased to 60 something percent. Then you can control by turning off the whole system. And now the pump. After pressing this button,
And this is to control the on and off of the soil detection system. So after the plant monitoring system sense that the leaf is yellow, it will send data to the MQTT and it will send signals to water tank to make sure it pumps water. And this is the logbook for the whole system.